9.3 Solubility. In this section, the learning goal is to define solubility, distinguish between an unsaturated and a saturated solution, identify an ionic compound as to if it's soluble or insoluble. So here, when it's talking about gout up here, it says attacks of gout may occur when the concentration of uric acid in blood plasma exceeds the solubility of 7 milligrams per 100 milliliters at 37 degrees Celsius. So if for some reason your issues have you getting more uric acid than 7 milligrams per 100 milliliters, then this is when you can get the gout. So they're talking about the solubility is 7 milligrams per 100 milliliters for the uric acid. Well, let's have some other examples, but let's learn a little bit more about solubility first. The maximum amount of solute that dissolves in a specific amount of solvent is the value of the solubility. It is temperature sensitive for solutes. Some are more than others, and it is usually expressed in grams of solute in 100 grams of solvent, and the solvent is usually water. So, as we look at the two different terms, unsaturated solution and then saturated solution, they're going to be opposites, obviously, but let's look at unsaturated solutions. They contain less than the maximum amount of solute. So here we have our water is the solvent, and we're pouring in salt, and it dissolves it all. Well, it's unsaturated because it's dissolved it all. As opposed to saturated solutions, we know when it's saturated, when not only did some of it dissolve, but there's still some here, which that's telling us if we have some undissolved solute, that means the solution is saturated and holding all that it can. And so the stuff that has dissolved is in this equilibrium and is recrystallizing and then dissolving and recrystallizing. So if it's a saturated solution, you'll know it's saturated by having seen a little bit of stuff at the bottom. It doesn't happen to be as much as doesn't have to be as much as this picture shows. All right, so let's label each of the following solutions as saturated or unsaturated. Salt dissolves when put in water. Well, there's your answer right there. It is unsaturated because you don't see any more once it's in there. B. Sugar added to a cup of water does not disappear but sits at the bottom of the cup. Well, that tells us that cup of water is totally saturated and it won't hold any more sugar because there's some sugar there at the bottom. All right, let's put some numbers here. At 40 degrees Celsius, the solubility of potassium bromide is 80 grams per 100 grams of water. Identify these solutions as either saturated or unsaturated. Okay, well, the maximum it can hold is 80 grams if you have 100 grams of water. So on A, we have 100 grams of water, and it says we just put in 60. Oh, well, it could hold 20 more, so that means this solution is unsaturated. Okay, B. 200 grams to 200 grams of water. Well, let's see here. If we had 100 grams of water, it could hold 80 grams. So if we doubled the amount of water to 200 grams of water, that would mean we could double the amount of KBr to 160. But notice they said 200. So that means that is, 40 grams more than it can hold. So that is a saturated solution because it's got more of the solute than what it can hold. C. 25 grams of KBr added to 50 grams of water at 40 degrees Celsius. Well, let's look and see. 100 grams of water can hold 80, so 50 grams of water would be half of that. So that meant that 50 grams of water could hold, what's half of 80, but 40, it could hold 40 grams of KBr. Well, it only added 25, so it's unsaturated. We could add more. All right, here's a nice graph that talks about the effect of temperature on solubility. Now, solubility depends on the temperature. Now, most solids, the solubility increases as the temperature increases. But the kicker here is the solubility of gases decrease as the temperature increases. So what that means is items that have gases in them, as you heat them up, the gases are going to become less soluble and want to escape. So let's go back and make sure we understand our solubility of gases. The solubility decrease if you have gas as you increase the temperature. And this is why, as you know, your soda pop, if you leave your soda pop in the hot car here in the summertime, they just might blow up and get your car all messed up. Not that that ever happened to me. It wasn't just one can of soda, it was a whole 6-pack. Okay, anyway, next question. Why do fish die in water when it's too warm? Well, because they're not really dying because they're frying. They're dying because they're suffocating. They're suffocating because when the water gets too warm, there's less oxygen in that water because of solubility decreases when you increase the temperature. So if there's less solubility, if there's less oxygen in the water for the fish, those fish are going to die. Now, do all fish die at the same rate? No. I mean, if you go fishing for carp, they don't need much oxygen at all. But if you go fishing for trout, they need more oxygen. And so different fish can survive in different temperatures of water. All right, solubility and pressure. Henry's law states that the solubility of a gas in a liquid is directly related to the pressure of that gas above the liquid. At higher pressures, more gas molecules dissolve in the liquid. Now, back in the last section, last chapter, we talked briefly about scuba diving and about the pressure of the gas molecules. And Henry's law is all about that here. Now then, in this section, soluble and insoluble ionic compounds, we're getting a little bit more specific on which ionic compounds are soluble, i.e. dissolve in water. Now, first of all, anything with a +1 charge, that's going to be soluble. If it's a -1 charge, they're all going to be soluble, except if they are combined with silver or our lead-2 or our mercury. So let's look at this just by knowing that. Mixing certain aqueous solutions produces insoluble ionic compounds. Now, barium sulfate is an insoluble ionic compound, and it's on purpose. When you go in and need to have them look at your innards, you have to drink the barium sulfate, then they take an x-ray of it, and because it's insoluble, it's used to enhance their x-rays. All right. So table 9.8 is kind of showing if something's going to be soluble or not by using the solubility rules. And you go, what solubility rules? Well, let's look back here to the solubility rules. Meaning everything with a +1 charge is going to be soluble. Everything with a -1 charge is going to be soluble, except when we combine them with silver or lead-2 or mercury. So let's look and see here. So K2S, it would be soluble because the first one is going to be potassium, which is a +1. It's in the first family. Calcium nitrate. Nitrate is a -1 charge, and they are soluble. Lead-2 chloride, it's insoluble. Lead's insoluble. Sodium hydroxide, Na is a +1, so that means it's going to be soluble. Aluminum phosphate, Al is not in the first column, so it is going to be insoluble. So why are each of these ionic compounds insoluble in water? Well, first of all, they're insoluble, but they're also beautiful, but they're also insoluble. And so you can tell they're insoluble because they don't dissolve. You can see the little parts of them. Well, the cadmium sulfate, cadmium's not in the first family, so it doesn't contain, and this sulfur is a -2, so no soluble ions. Here we have our iron 2 sulfide, ditto. Okay, lead 2 iodide, anything connecting with lead is insoluble. Nickel hydroxide, no, our nickel is not in the first family, so it is going to be insoluble.